All right, so our final task of this exercise is a variance comparison analysis. And this is a continuation from our last hypothesis test, which was an ANOVA test to analyze if the global surface temperatures were significantly different from season to season. And I was surprised to see that there was no significant difference that we found in that ANOVA test. And we're using the same data set that we pulled from Kaggle, which was collected by NASA. And we alter our research question to ask, is there a statistical difference in the variance of temperature anomalies between the decades 1950 to 1959 and 2010 to 2019? And we decided that the Levene's test to assess the quality of variances was the appropriate test. And our null hypothesis is that there is no statistically significant difference in the variance temperature anomalies between those selected decades. And the alternative hypothesis is there is a statistical significant difference in the variance of temperature anomalies. So for our null, we would expect all the variances to be equal, and alternative, at least one of those not to be equal. And we filtered some of this data out to just get our selected decades. And we calculate the yearly average temperature for each year, split the data into the selected decades, and here we conduct our Levene's test. And with this Levene's test, we set our significance level at 10%, and our p-value, we get back 0.4645, and that is higher than our given alpha level. So we fail to reject the null hypothesis and conclude there's no statistically significant difference in the variance of average temperature anomalies between the selected decades, 1950s and the 2010s. And with that Levene's test, we have some assumptions that follow. Typically, you run your normality test before conducting the hypothesis test to make sure you're conducting the appropriate test for your distribution. We had random sampling by a credible source, which was NASA, and we had selected random years from the data set that spanned from 1850 to 2023. Our measurement scale is on a continuous scale for temperature, and each recorded temperature anomaly in the data set is in an independent measure. So our assumption of independence of observations is met. Next, we assess the normality. We use a Shapiro-Wilks test for this, for the yearly averages. And after running that Shapiro-Wilks test, we conclude that the yearly averages deviate from the normal distribution. And we create a QQ plot and histogram to further assess this visually. As you can see, we have some tails over here, and it doesn't follow that line as we'd like for a normal distribution. You can see it's probably slightly skewed right. And the Shapiro-Wilks test isn't the best for big data, and for this data set, we aren't using the largest selection, so it should be okay. And after using the z-score method to assess outliers, we find that there are no outliers in this data. Consequences of violating that normality assumption is reduced test power, and this makes it harder to detect true differences or relationships when they exist. And this also can lead to a misleading p-value. And some remedies for these violations are increasing the sample size, which will in turn help the central limit theorem that suggests that the sampling distribution of the sample mean becomes normally distributed when increasing that sample size, or using non-parametric tests such as the Mann-Whitney test, which is more robust against the normality assumption. And another remedy that is always useful is transforming the data, which sometimes makes it harder to interpret. And some Python tools we use for this hypothesis test, like the Levene test and Shapiro test, is the Skippy library, pandas to load the data in and handle some of the manipulation, and Seaborn and Matplotlib for those visualizations and labeling the axes. Here's some links to where we pulled our data from. This data definitely does need some more analysis to maybe fix that normality assumption, and again, interpreting the results, we concluded that there isn't a significant change of global surface temperature from the 1950s decade to the 2010s decade. And that concludes my video. Thank you.